Hello students, welcome to today's chemistry class on the topic hybridization. What is hybridization? Hybridization is the mixing of two or more atomic orbitals to obtain a single atomic orbital that is called a hybrid orbital. The mixing of two or more orbitals to obtain a hybrid orbital. Before we go further to understand what hybridization means, you need to go back to the electron configuration of carbon. Carbon is element number 6 in the modern periodic table. And the simplest way of writing the electron configuration of carbon is 2, 4. That means 2 electrons in the first shell and 4 electrons in the second shell. The electron configuration of carbon can be written using SPD notation. Do you remember off-ball principle? That is 1s2, 2s2, 2p2. Do you remember Horn's rule in your SS1? Representing the electron configuration of carbon in boxes like this. Do you remember that in your SS1 you were taught that each of these boxes represents a degenerate orbital? What is a degenerate orbital? Degenerate orbitals are orbitals that have equal energies. P orbitals have three degenerates, and those degenerates are these boxes here: px, py, pz. And the electron configuration we see here, which is obeying Horn's rule, the two arrows in this box are referring to the two electrons that we have in s orbital of first shell. And then these other two arrows are referring to two electrons in s orbital of second shell. And then this arrow and this arrow here, did you notice that the first one is in p orbital, px orbital, px degenerate orbital. The second one is in py degenerate orbital. What does that mean? It means that when you have an atom of carbon which does not have energy given to it, that atom is in the ground state. And when it is in the ground state, the electron configuration of carbon is what we have on the board. Here we are obeying Horn's rule. We are using electron box diagram, and we describe this as the ground state electron configuration of carbon using the SPD notation and the electron box diagram, which obeys both the off-ball principle and the Horn's rule. Ground state is like something on the ground, relaxed. Is it possible to take something off the ground and take it to a higher place where it is not stable, where it is excited, when it acquires energy? Yes. When an atom of carbon is given energy, it becomes excited. And what is the excited state electron configuration of carbon? On the board, we have this same electron box diagram up here, but see, something has happened. In the first degenerate orbital, we still have 2 electrons. But in the second degenerate orbital, did you notice that we do not have the 2 electrons we had here? What has happened? When energy is given to an atom of carbon in ground state, the electrons here acquire the energy, and one of the electrons becomes promoted to this point, this pz empty degenerate orbital. It becomes promoted, it becomes excited. Do you understand? What happens next? For this atom that has become excited to bond with other atoms, we are going to do what we call hybridization. We are going to mix either one s orbital here with one p orbital, which is what is happening here. One s orbital is mixing with one px orbital to give us what we call sp hybridization. Do you understand? What if one 2s orbital here, this orbital mixes with 2p orbitals? What kind of hybridization are we going to obtain? we obtain two sp2 hybridization. That is p degenerates, two of them, and then s degenerates, only one. It gives us sp2 hybridization. What if we combine this, 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 and this? What kind of hybridization are we going to obtain? We obtain what we call sp3 hybridization. sp3 means one s orbital and then three p orbitals. That gives us what we call sp3 hybridization. What next happens? What is the shape of s orbital? It is spherical in shape. P orbital is dumbbell in shape, as is illustrated here. Dumbbell in shape. Now that we have excited an atom and then we have carried out hybridization, the atom is going to take part in bonding. What is going to happen? How is the bonding going to take place? It's possible for one atom, for one orbital to combine head-on with another orbital, head-to-head overlap. That gives us what we call sigma bond, as can be seen here. This is an orbital that is in head-on overlap with another orbital. That gives us sigma bond, a very strong bond. What if the orbitals overlap sideways, as you can see here? Side by side overlap. What kind of bond do we obtain? That's pi bond, which is weaker than sigma bond. So you see hybridization illustrated here. And where do we find each type of hybridization on the board? sp hybridization is found in alkynes. sp2 hybridization is found in alkenes, where you have double bond. sp3 hybridization is found in alkanes, where you have single bonds all through saturated hydrocarbons. sp is found where we have triple bond. Do you understand? Which of the bonds here are we going to call sigma bond? And which one are we going to refer to as pi bond? Pay attention, let's explain that as the last thing. This bond here, the bond here, the first one is the sigma bond. It is formed by head-to-head overlap of two atomic orbitals. Do you understand? What about the remaining two bonds here? What kind of bond do we have there? It is a pi bond. Why do we call it a pi bond? Because they are formed as a result of sideways overlap, side-by-side overlap of orbitals. Do you understand? Then down here, we have a double bond. Don't forget that when we have a double bond, the bond down here is the sigma bond. And then the one up is the pi bond. What about the last one where we have sp3 hybridization? Do we have any pi bond at all? No. What we have is sigma bond, a strong bond. The sigma is spelled S-I-G-M-A, but it's pronounced Z, sigma bond. Do you have any question? If you have any question, you can drop it on the comment section. We'll look at it in our sources.